So you learned that matter may be classified according to its physical state, which may be solid, liquid, or gas. Each physical state has properties. These properties are explained by the particle model of matter. Now in this chapter, you already learned other ways of classifying matter. You will also learn how mixtures of matter can be separated. So, can all components of matter be separated? So let's start with that. So in pure substances like elements, there is only one type of element present. Thus, it cannot be further separated anymore into simpler substances. However, in compounds, the component elements are chemically combined and cannot be separated through physical means. So for example, these are the elements and compounds combined together, which this is some of these the green and purple elements, as you can see, combined together, turning into compounds. Like what I said earlier, in pure substances like elements, there's only one type of element. Thus, it cannot be separated anymore. In compounds, however, the component elements are chemically combined by the two elements, which can be either separated by the use of heating. Now, heating can be used to separate elements of a compound. You'll also further learn about separating compounds and chemicals when you go to grade 7 and grade 8. But right now, let's talk about how they are separated by means of techniques. So, ways to separate salt and sand. Some can be done by physical separation first. Okay, the components of a mixture can be separated by physical means. The most common separation method used for heterogeneous mixtures are hand-picking large particles of solid mixtures, filtration of fine insoluble solid particles in liquid mixtures, and sedimentation and decantation of large insoluble particles in liquid mixtures, and just as well as distillation of homogeneous mixtures. Here is an example. So, pure water, of course, combined together with, can be separated by into a component elements. Hydrogen and oxygen can be separated by passing electricity to it. Now, the component salt or NaCl can also be separated by into component elements using electricity. Like for example, as you can see here, this is how salt is separated from each other. Okay, by means first of hand picking, like for this one example again. Now, we already talked about parts of the matter that can be classified into pure substances and mixtures. Okay, we're already done with this part. Now, we're going to talk about the following things at the site of mixture: sedimentation, decantation, filtration, distillation, magnetic separation, and crystallization. Now, on page 45, if you already have your book, we have here sedimentation. Sedimentation is the process that allows the sediments or solid particles to settle at the bottom of a container. Quite easy to understand. So we have here, for example, you get mud, then mud with water. Then eventually, all of the insoluble impurities will eventually go down. Okay? And leaving some parts of the water on top. So that's sedimentation. Okay? Now, combining this one with another separating technique would be decantation. But we'll talk about that for later. Now, about sedimentation, once again, after the particles have settled, the clear water is what we call a supernatant liquid. Okay? Let's go back. The one on top, the clear water, is what we call a supernatant liquid. So look, supernatant liquid. And at the bottom would be what we call the insoluble impurities. Let's go to decantation, just like I said earlier. So after sedimentation, after the particles have settled, the clear liquid is carefully poured into another container without disturbing the sediments. So Again, the supernatant liquid is going to be now transferred to another container. Like for example, again, the clear water here, which is the supernatant liquid, will now be in the process of decantation to be separated. So, some examples would be using a glass rod to help in decantation. Now, next example would be filtration. Filtration is the process of separating solid components from liquid or gas components using a filter or filtering medium, like filter paper. You can see that there are different types of filtering techniques that we can see here in the picture. Now, by the use of filter paper, that's very common. You can see that there are larger and smaller pores that is filtered out into these holes. So the process of separation of solid components from liquid or gas components using a filter or filtering medium like a filter paper. So the mixture is carefully poured into the filter paper with the aid of a glass rod. So the solid particles called the residue remain on the filter, while the clear liquid called the filtrate passes through the filter paper and is collected to another container. So at this part, as you can see, we have the filter paper. The one that is going to be left behind is what we call the residue. Okay? Now, the filter paper, while the clear liquid passes through the filter paper, once again is collected to another container, is what we call the filtrate. This one is the filtered liquid called the filtrate. Now, filtration is also used in proper maintenance of air conditioning. This one is a bit dirty already. They didn't clean. But the amount of the things that are already filtered in this one would be a great amount already, meaning it needs to be cleaned. Air conditioning units contain air filters to eliminate dust particles. Cars and buses have oil filters to prevent dust and solid particles from interfering in motion of the engine and its parts. Now we're still going to talk about this part as filtration. Now, sieving is also known as sifting. We're still part of filtration. Now, sieving is a method of separating finer particles from bigger particles by using a sieve. It is like filtration that uses a sieve or mesh strainer instead of a filter paper. Now, you already understand that this one is used for cooking. So a sieve or strainer is used to break up clumps of flour. Sedimentation, decantation, and filtration are useful in water purification. Water taken directly from its source contains impurities such as harmful microorganisms and dissolved and undissolved substances. That makes water unfit for drinking. So, to purify water, suspended particles are filtered out, as you can see in the picture. Again, to purify water, and some of you already have, if you're familiar with Laguna water, this is how they, this is just some of the examples on how they filter it. Okay, but let me try to explain it to you again. Again, to purify water, suspended particles are filtered out while substances that are heavier than water are made to settle out through by means of sedimentation here. And removed through decantation. Well, it's not shown here, but it's also a part of the small process of decantation. Then going through filtration, harmful microorganisms such as disease-causing bacteria are eliminated by boiling the water by adding some chemicals to destroy them. Now, it's our part to do that because our tap water is not really good. It contains microorganisms that may cause to have us diarrhea and some other things that can make us sick. So this is filtration, combination of the sedimentation, decantation, and filtration at the same time. So these things can work together. So as you can see here, it's an example of how coffee is being filtered. I know some of you have already entered some of the coffee shops already, like the famous Starbucks. Some of them, they filter using filter paper still. Now we're already at page 46 of the book. Now distillation is a homogeneous mixture. Now distillation is the action of purifying a liquid by a process of heating and cooling. So how do we understand this in an easier way? So at first, this part, when a mixture like a salt is heated, the component that has the lower boiling point, water is changed into vapor. So again, this part is going to be boiled. Now all of the vapors here, like in part, of course, when you boil something, it's going to evaporate. The evaporation part or the vapors will be trapped in this container. Now, those vapors will eventually go down to turn into what we call a distillate. Okay? So the vapor continues into the condenser. So what can we remember about condense or the word condenser? That would be condensation, evaporation, then vapors, then condensation, like the clouds. That's why we can see sweat in these glasses. Well, not really technically in the picture, but as we imagine, if it's cold or really hot, we can see condensed water vapor that is made here. Now, going back, again, distillate is the one that is how we separate these types of mixtures. Okay? Like for example, again, the vapor rises, gets out of the flask. Here, this is the flask. Moves into an inner tube or what we call a condenser. The outer tube of the condenser contains free-flowing water that cools the vapor. So this one is the water. So this is not just an empty, no? This is how it cools down the vapors. Then, these vapors turn into distillate. The distillate is collected into another container. The thermometer is used to check if the temperature does not go beyond the boiling point of the substance being separated so that the flame can be adjusted. So distillation continues until no more vapor of the substance being separated gets out from the mixture. So distillation is important in the process of creating petroleum and wine industries. So crude petroleum is distilled to obtain different products such as gasoline, diesel, fuel, kerosene, lubricating oil, and petroleum products. So I think this is brand new to you guys. So again, look, this is a crude, they collect crude oil and by the process of distillation, we can create gases, naphthalene, gasoline, kerosene, so on and so forth here, and can be used in different kinds of ways. Now, I think you're already familiar with this one, and as I mentioned, distillation is also done by wine industries. Wine is produced from fruits like grapes. Alcoholic beverages such as brandy, vodka, gin, and whiskey are made from wine through distillation process. So different types of examples here of how it's going to be distilled and created. Sometimes special techniques are used to separate the components of mixtures. So we're going to different kinds of ways already. So I mentioned the common ones. This one, we'll talk about special techniques. These include magnetic separation, crystallization, sublimation, and chromatography. Now, magnetic separation is used to attract magnetic substances like iron, metals, and separate them from non-magnetic substances. Like for example, separating combination of a sulfur and iron. Now, iron fillings are separated using a magnet from sand. Iron nails are separated from glass chippings using a magnet too. This process is commonly used in mining, where magnetic materials like iron ore or extracted, which is extracted from soil. And the most common thing that we see in the TV shows are landfills and junkyards using strong magnets to segregate metallic objects from other materials. So take note, we're already on page 47. Going now to crystallization. Crystallization is how rock candies are made. Complete evaporation of water results to the formation of salt crystals. Seawater, not only by means of creating rock candies or lollipops, but also seawater is collected from a clean source. Water is made to evaporate through heating. As water evaporates, the salt solution becomes more concentrated and crystals of salt begin to appear. So this is one common example that we don't really look at that much. But these salt substances are crystallized, okay, by means of crystallization. Complete evaporation of water results to the formation of salt crystals. Like this one, for example. You can pause the video and analyze how the most common evaporation and crystallization is made by means of separating the water and turning it into some of the crystals here as an example. Next would be sublimation. Sublimation is used to separate components of solid mixtures. So you might think this one is the same as sedimentation and decantation. But sublimation, like for example, when a mixture of a chalk powder and ammonium chloride is heated at a low flame, ammonium chloride leaves the dish in gas form. The sublimes is in the upper portion of the funnel. So this one is the funnel. So again, it turns into gas, goes part on the upper part of the funnel. The temperature is lower than the temperature of the dish. The chalk powder remains in the dish while ammonium chloride is collected by scraping them carefully from the funnel using a spoon or spatula. Sublimation can also be done commonly by how some clothes are printed. Sublimation printing on fabric. Not only these chemicals, but also how we apply it in our daily lives. And of course, for businesses. Now, you have to listen carefully, or you can eventually just go back and try to research yourselves. But this one is a bit complicated to understand. But I'll do my best to tell you how chromatography works. Now, by definition, chromatography separates the different components of a mixture using an absorbent. The most common form of chromatography is paper chromatography. Paper chromatography uses a stationary phase and a mobile phase. Now, paper chromatography is used as a qualitative analytical chemistry technique for identifying and separating colored mixtures like pigments. What are pigments? These are colors. It is used in scientific studies to identify unknown organic and organic compounds from mixtures. So this is our takeaway in how we understand chromatography. So how do we understand paper chromatography in a stationary phase and mobile phase? Like for example, a strip of filter paper is used as a stationary phase. Okay, this one, the filter paper is the stationary phase. While a solvent like water is used as a mobile phase. So if you can try to remember what we already studied through the pure substances and mixtures, you can already get on how chromatography is going to work. Now, a spot of a mixture of dye is placed near the bottom of the filter paper. It carries the colored component of the mixture as the solvent soaks up. The different components of a mixture will move at different speeds. You can see these at the bottom would be the colors and how these colors transfer. What I mean is that move at different speeds. Some components travel farther and others causing different colors to spread. So not only that we can see that this one is a brown color, eventually you think that it's just going to be a brown color until the top. No. So some of the colors are going to be separated at this point. Some are strongly attracted to the paper so that they readily absorb the water, absorbed by the paper, sorry. Others that are weakly attracted to the paper move slower, while the component that is not attracted to the paper remain in the original position. If the component is not attracted to the paper, it rises at the same rate as mobile phase. So again, stationary phase can be intertwined with the mobile phase, but stationary phase, for example, is like the filter paper, while the water is our mobile phase. So, how do we understand again these separating techniques? By starting out of what matter may be classified into pure substances, like an element and compound. Again, an element cannot be separated anymore, but a compound is a combination of the two elements that can be separated by a lot of means. Like for example, heating. Now mixture, like what I mentioned here, I didn't put here chromatography, but chromatography is also part of separating mixtures. One of the special techniques. So what's one of the common techniques would be sedimentation. Then three things added to the common things would be decantation, filtration, distillation. Now, special techniques would be magnetic separation, crystallization, sublimation, and chromatography.